Sandbox Escapes and the Offensive AI Arms Race. AWS Bedrock AgentCore advertises a sandbox network mode for its code interpreter service, the execution environment where AI agents run Python, JavaScript, or shell commands on behalf of users. According to BeyondTrust Phantom Labs, that sandbox has a hole you could drive a DNS tunnel through. Researcher Kennard McQuaid discovered that sandbox mode permits public DNS resolution despite marketing language promising complete isolation with no external access. Phantom Labs built a full proof of concept, a custom DNS command and control protocol that encodes commands as chunked ASCII and DNS-A records and exfiltrates data via long subdomains. The result? A bidirectional interactive reverse shell inside what was supposed to be a network-isolated Firecracker micro-VM. The attack chain is worth understanding in detail. Commands are delivered through DNS-A record responses where the first octet signals continuation 10 or termination 11, and octets 2 to 4 carry ASCII values of base 64 encoded characters. Output exfiltration embeds base 64 data in DNS subdomain queries with cache-busting fields to ensure each query reaches the attacker's server. Phantom Labs demonstrated listing S3 buckets, reading files containing PII and credentials, and accessing financial data, all through a code interpreter instance configured for no network access. The kicker: AWS's AgentCore Starter Toolkit default role grants full S3 read access to all buckets, full DynamoDB access, and full Secrets Manager access. An overprivileged IAM role combined with a leaky sandbox is a data breach waiting to happen. AWS ultimately declined to patch the issue, instead updating documentation to note that DNS resolution is enabled to support successful execution of S3 operations. They awarded the researcher a $100 gift card and a CVSS 7.5 score. The defensive posture here matters. Code interpreters are the execution endpoints for AI agents. Prompt injection, supply chain compromises in the 270-plus bundled Python packages, and adversarial code generation all provide realistic paths to attacker-controlled code execution. When the sandbox is the last line of defense and that sandbox leaks DNS, the isolation guarantee collapses. Organizations running AgentCore should inventory their code interpreter instances immediately, audit IAM roles for least privilege, and migrate sensitive workloads to VPC mode with Route 53 Resolver DNS firewall. Meanwhile, the offensive AI security market just got a $1 billion vote of confidence. xBow raised $120 million in Series C at a valuation exceeding $1 billion. Founded by Uwej Damore, creator of GitHub Copilot and GitHub Advanced Security, xBow applies AI reasoning and adversarial workflows to find vulnerabilities at machine speed, claiming top placement on the HackerOne leaderboard. The round was led by DFJ Growth and Northzone, with Sequoia, Altimeter, and others participating. AI Cyber Magazine's Winter 2026 issue provides broader context on the intersection of artificial intelligence and cybersecurity, covering in-depth analysis, technical how-tos, and thought leadership across the field. Agentic coding goes industrial. Stripe merges over 1,300 AI-written pull requests every single week. Zero human-written code in those PRs. The architecture behind that velocity is what Stripe calls blueprints, structured workflows that alternate between deterministic steps linting, type checking, CI pipelines, and agentic steps where the coding agent reasons and writes code. The interleaving is the key insight. Deterministic guardrails constrain AI output at each stage. The AI handles creative reasoning between those guardrails. This hybrid pattern has independently converged across multiple major engineering organizations. Shopify built an equivalent system called Roast. Amazon attributed savings of 4,500 developer years to the same architecture, and Airbnb migrated 3,500 test files in 6 weeks using it. The lesson is not that AI writes good code on its own. It is that well-designed agent harnesses with deterministic validation checkpoints unlock reliable, scalable AI coding. If Stripe represents the volume play, Mistral's Leanstral represents the correctness play. Leanstral is the first open-source coding agent designed specifically for Lean 4, the proof assistant capable of expressing complex mathematical objects and software specifications. With just 6 billion active parameters via a highly sparse mixture of experts architecture, Leanstral outperforms models 1060x its size on FLTVol, a new benchmark that evaluates formal proofs and correct mathematical definitions in realistic repository PRs rather than isolated competition problems. At pass at 2, Leanstral scores 26.3. Beating Claude Sonnet 4.6 by 2.6 points while costing $36 versus Sonnet's $549. Even at pass at 1.6, where Leanstral reaches 31.9, it costs 92x less than Claude Opus 4.6. The model supports MCP Model Context Protocol through Mistral Vibe, was specifically trained to work with Lean-Lisp MCP, and ships under Apache 2.0. The practitioner perspective comes from Hamilton Carter, who has been building with Gastown, an agentic coding platform where Claude agents carry out development tasks autonomously. Carter describes how he and his kid built a Morse code game CW Simon by writing a software requirements specification and having polcats, Gastown's term for agents, execute the tasks. The workflow is not frictionless. Carter encountered zombie polcats, agents coerced into existence with no work to do. When the system's mayor agent misreported project status, the fix was pragmatic. Never ask yes/no questions, always request actual CLI output. On the final bug fix, Carter asked the mayor for rig status and discovered the work had already been completed, merged, and pushed while he was typing his query. The pattern is consistent with what the industry is converging on. Agents as productivity multipliers with human judgment applied at the specification and verification boundaries rather than in the coding loop itself. The agent tooling stack matures. The infrastructure layer beneath coding agents is filling in fast. RTK Rust Token Killer is a single binary CLI proxy that filters and compresses command outputs before they reach LLM context. The savings are substantial. In a 30-minute Claude code session, RTK reduces approximately 118,000 tokens to 23,900, an 80% cut. It works by transparently hooking into Claude Code's bash tool calls, rewriting commands like get status to RTK get status and applying 4 strategies. Smart filtering, removing boilerplate, grouping, aggregating files by directory, truncation keeping relevant context, and deduplication collapsing repeated log lines with counts. A git push that normally consumes 200 tokens becomes a single line. OK main at 10 tokens. Test output drops 90%. The tool is MIT licensed, homebrew installable, and written in Rust with sub 10 milliseconds overhead. One layer up from token economics sits agent packaging. AgentClip is a Go-based AI agent built on the Pinux platform that packages an entire agentic loop. LLM calls, tool execution, semantic memory search, browser vision, and clip-to-clip invocation into a deployable .clip archive. The architecture uses a 3-layer model: workspace source code, package immutable zip, and instance runtime with mutable data directory. The agent supports topics named conversation namespaces, runs agentic loop cycles with multiple LLM calls and tool executions, and 3-tier memory persistent facts, LLM-generated summaries, and cosine similarity search over embeddings. Commands pipe together CMD1 vertical bar, CMD2 and CMD3, browser screenshots auto-attach as vision content, and cross-clip file transfer enables multi-agent collaboration. At the application layer, Dreamlab OctoBot demonstrates what a fully autonomous local agent looks like when pointed at creative work instead of code. Running entirely on Ollama default model, Gemma 3:4, B, OctoBot executes a continuous loop. Pick an idea domain, invent something, save it to a markdown vault, fuse past ideas into hybrids, and follow idea chains deeper. Leave it running overnight, and you wake up to hundreds of fully written idea pitches. The pixel art game interface tracks 15 environments, achievements, and inventor levels. The privacy pitch is real. Everything stays local, no cloud, no API calls, unless you explicitly configure an alternative backend. It is whimsical but structurally interesting as a reference implementation for autonomous creative agents with persistent memory and knowledge ingestion. Memory that outlives the session. Every AI coding session starts from 0. You re-explain your project structure, your naming conventions, your opinions about barrel exports. The model nods along, produces reasonable code, and forgets everything when the session ends. Most MCP memory servers solve basic session persistence. Pi, the collective intelligence system built on the RuVector platform, tries to solve a harder problem. What if knowledge compounded across sessions, across developers, across projects? Every piece of knowledge entering Pi gets packaged into a cognitive container using the RVF binary format, carrying vector embeddings, witness chains tracking who contributed what, ED25519 digital signatures, and SHAKE256 integrity hashes. The search layer runs HNSW-indexing over a graph neural network where memories are nodes and similarities are edges, with min-cut-based self-organization, so you never have to decide whether JWT refresh token rotation belongs under security or authentication. The security model is what distinguishes Pi from simpler alternatives. It assumes every input is adversarial, running 7 defense layers. Input sanitization with PII stripping, cryptographic verification via SHAKET56 and ED25519, embedding space validation rejecting nan/imp/magnitude outliers, rate limiting with single-use nonces, 2 sigma statistical exclusion for outlier contributions, reputation scoring weighted by accuracy squared times uptime times stake, and anomaly detection via spiking neural networks. The Byzantine's fault tolerance layer uses FEDOV with BFT for knowledge aggregation. No single contributor can shift what the system considers true. For a solo developer, this is overkill. For teams or open source communities sharing patterns across projects, it is load-bearing infrastructure. On the forensic side of memory persistence, wechat-decrypt is a cross-platform tool that extracts encryption keys from running WeChat 4, docks processes, and decrypts all local SQLCipher 4 databases. WeChat 4.0 uses AES256 CBC with HMACSHA5 12PBKDF2 HMACSHA5 12 at 256,000 iterations and independent salt and key per database. The tool scans process memory for cached raw keys, a 64-hex encryption key plus 32-hex salt pattern, validates them against page 1 HMAC, and decrypts everything. Session lists, chat history, contacts, media indexes. It includes a real-time web UI with 30 ms wall polling, SSE push, and about 100 ms total latency. An MCP server integration lets Claude Code query WeChat data directly. The tool works on Windows, Linux, and macOS via MachVM API, covering the platforms where forensic access to encrypted messaging databases matters most. Open models and the local inference push. Mistral released Mistral Small 4, 119B, 2603, NVFP4, an official NVFP4 quantized version of their 119 billion parameter model. NVFP4 is NVIDIA's 4-bit floating point format, distinct from the GGUF and AWQ formats that have dominated local deployment. An official vendor quantized release signals that hardware-specific quantization is becoming a distribution strategy, not just a community aftermarket. The model targets NVIDIA GPUs with native FP4 support, which means Blackwell and newer architectures get optimized inference without the quality trade-offs of post-hoc quantization. On the community side, Omnicoder Claude 4.6 Opus Uncensored, GGUF continues the GGUF format's dominance as the de facto standard for local model distribution. The hardware story extends beyond NVIDIA. AMD NPUs on Linux are now capable of running LLMs. A meaningful shift for an ecosystem where AMD has long been the underdog in AI inference. NPU neural processing unit architectures execute transformer layers with dedicated hardware acceleration rather than repurposing general-purpose GPU compute, offering better power efficiency for sustained inference workloads. Linux support matters because it opens the door to server-side and embedded deployments where Windows is not an option. Meanwhile, Rick Beato, a YouTube creator with millions of subscribers primarily covering music production, drew a parallel between AI's trajectory and the music industry's digital disruption, arguing that local LLMs will win over centralized services for the same reasons independent music distribution eventually prevailed over label gatekeeping. The cultural signal matters. When mainstream creators outside the AI bubble start advocating for local inference, the technology is crossing an adoption threshold. Training at million token scale. Training large language models on long sequences has become essential, but the attention mechanism scales quadratically with sequence length. And even flash attention only reduces memory, not compute. Ulysses sequence parallelism. Part of Snowflake AI Research's Arctic long sequence training protocol, provides an elegant solution by distributing attention computation across multiple GPUs through attention head parallelism. The key insight: attention heads are independent. Ulysses splits input sequences along the sequence dimension, uses all-to-all collective operations to redistribute data so each GPU holds all sequence positions, but only a subset of heads, computes attention locally, then reverses the redistribution. Communication volume scales as ONDP per GPU, a factor of P less than ring attention's ONDB via sequential point-to-point transfers. The practical results on H180GB GPUs are compelling. With SP=4 per GPU, memory drops 3.3x at the same sequence length, enabling training at up to 96K tokens on 4x H100s 12x longer than the data parallel baseline of 8K. At 64K tokens, SP=4 achieves 13,396 tokens per second, 3.7x the baseline throughput. The all-to-all communication overhead is minimal on NVLink connected GPUs, so the real benefit comes from processing proportionally more tokens per step as sequence length grows. Ulysses is now integrated across the Hugging Face ecosystem. Accelerate, Transformers Trainer, and TRL's SFT Trainer all handle sequence sharding, loss aggregation across ranks, and pre-shifted labels automatically. The constraint is that sequence length must be divisible by the SP degree, and the number of attention heads must be at least equal to the SP degree, which makes ring attention the fallback for models with few heads. Physical AI finds its training data. Healthcare AI has been predominantly perception-based, models that interpret signals and classify pathology. What healthcare involves doing, and the static datasets of the past lack embodiment, contact dynamics, and closed-loop control. OpenH Embodiment is a community-driven dataset initiative spanning 35 organizations including Johns Hopkins, Stanford, NVIDIA, CMR Surgical, and UC Berkeley that builds the first large-scale foundation for physical AI in healthcare robotics. The dataset comprises CCBY4, .0 training data across simulation, benchtop exercises like suturing, and real clinical procedures, using both commercial robots CMR Surgical, Rob Surgical, Tuadao, and research platforms DVRK, Franka, Kuka. 2 models ship alongside the data. GR00TH is a vision language action model for surgical robotics, derived from NVIDIA's Isaac GR00TN series and trained on roughly 600 hours of OpenH embodiment data. It uses a learnable MLP to map each robot's specific kinematics to a shared normalized action space, drops proprioceptive input during inference to create a learned bias term per system, and injects instrument names directly into the VLM task prompt. A prototype has demonstrated end-to-end suture execution. Cosmos H Surgical Simulator is a World Foundation model fine-tuned from NVIDIA Cosmos Predict 2.52b that generates physically plausible surgical video directly from kinematic actions. For 600 rollouts, simulation took 14 hours versus 400 hours on real benchtop hardware. In a different domain, but with related sparse data challenges, InstantSplat++ extends Gaussian splatting to sparse view large-scale scene reconstruction, supporting 3DGS, 2DGS, and MIP splatting from just a handful of input images rather than hundreds. Governance gaps and labor anxiety. The International AI Working Group IAWG takes a different approach to AI governance than the top-down frameworks dominating policy discussions. Built on the Matrix protocol, the same decentralized, end-to-end encrypted communication standard used by Element and others, IAWG creates a network where members register their agents, tools, and services in machine-readable manifests. Agents from different members communicate directly through custom Matrix events, delegating tasks and combining expertise without manual orchestration. The architecture has 5 layers: hierarchical organization via matrix spaces, standardized agent manifests, cross-room agent communication with coordinator orchestration, a searchable registry with sandbox testing, and cross-signing verification with ODC for external authentication. Tribes. Cross-member coalitions organized around societal challenges like climate, healthcare, and responsible AI. Pool agents and expertise for larger goals. Whether governance mechanisms can keep pace with the displacement they are meant to manage is an open question. Anthropic CEO Dario Amodei predicted that 50% of entry-level white-collar jobs will be eradicated within 3 years. The Reddit discussion captured the range of practitioner responses. One commenter noted their CEO wants to eliminate the shittiest parts of people's jobs, so merchandisers can explore new products instead of typing into ERPs. Another pointed out the demand-side problem: who's going to buy shit when you wipe out 50% of the middle class? Several dismissed it as fundraising-motivated doom, a new day, a new number pulled out of someone's ass. One developer using AI daily for vibe coding noted that despite increased individual productivity, their team size has not changed. The pattern is familiar. AI leaders making bold displacement predictions while practitioners report augmentation rather than replacement. But the specificity of 50% in 3 years for entry-level roles adds urgency to a conversation the industry has been having in vaguer terms.